So 3.2, we're going to be talking about the product rule and another rule called the quotient rule. So let's look at something to help us see why we need a product rule. So if I had the function f of x equals x squared, we already know what its derivative should be. What's the derivative of x squared? 2x. So let's try to write this in a different way. What if I had f of x equals x times x? Okay. Well, what if I just try to take the derivative of each of the factors separately? Well, then f prime of x, well, what's the derivative of x? 1, and the derivative of x is 1. So then this gives me 2. That's a problem, because they're not equal. So what does that tell us then? This says that the derivative of the products is not the product of the derivatives. So for addition and subtraction, we could just do them separately and get the correct answer and then add and subtract at the end. With multiplication, that is not true. Hence, we need a new theorem or a new rule named product rule. So the product rule states the following. If f and g are both differentiable functions, then the product of f and g is also differentiable, and is given by this formula. So d dx of f times g is f g prime plus gf prime, or f times the derivative of g plus g times the derivative of f. So this is just a formula, or a theorem, if you will. So to use this formula, we need to know f, we need to know g, we also need to know f prime and g prime. So we'll be given f and g, we'll have to calculate f prime and g prime, and then we just put everything into our nice formula. And we're done. All right, so let's go ahead and take a look at our first example. So we wish to find the derivative of y equals x times e to the x. So the first thing we need to do is use the product rule. So and I am going to identify f as x. So that's my first factor. And I'm going to identify g as my second factor, which is e to the x. So then to use my product rule, I also need to know f prime and g prime. So the derivative of x is going to be 1. And the derivative of g, this is our favorite derivative. The derivative of e to the x is e to the x. So then our derivative, y prime, is going to be, according to our rule up here, f times g prime. So it's going to be f g prime plus g f prime. So plugging all of that in, we're going to get x times g prime plus g times f prime. So then we get y prime is equal to x e to the x plus e to the x. I left my x off up here. And then if you wish, you can factor out your common e to the x, and you get x plus 1 times e to the x. So that's the derivative of x e to the x is x plus 1 e to the x. So basically, to use the product rule, we identify our factors, f and g. We calculate each of their derivatives, f prime and g prime. And then we just plug them into our formula, f g prime plus gf prime, and simplify, and we're done. So this is our theorem for taking the derivative of a product. All right. So the first thing we identify is f is x squared plus 2, and our g is e to the x. So f prime is going to be 2x, and g prime is going to be e to the x. So then y prime is g, or is f times g prime. So we get x squared plus 2 times g prime, which is e to the x, plus g times f prime, which is e to the x times 2x. And that's a perfectly good answer. If you really feel like it, you can factor out your common e to the x, and you get x squared plus 2 plus 2x times e to the x, or x squared plus 2x plus 2, writing in descending order. All of those are correct versions of the derivative. Depending on what we're trying to do, you might really want it like we have in the last form, or if you're going to take more derivatives, that can also be helpful as well. All right, so let's take a look at example B. So example B, we look at it, what would we identify as f, and what would we identify as g? Well, our f is going to be the square root of x, but we can't differentiate the square root of x. We have to use our fractional exponent rule to write it as x to the 1/2 power. Then we can use the power rule to take its derivative. We then have g of x is what's left over, so that's 2 minus 3x squared. We take our derivative, so f prime is going to be 1/2 x to the negative 1/2, and g prime is going to be negative 6x. So our derivative this time, f prime of x, is equal to f times g prime, so x to the 1/2 times our g prime, which is negative 6x, plus g times f prime, so 2 minus 3x squared times g prime, or times f prime, is 1/2 x to the negative 1/2. So then, if we wanted to simplify, we multiply these together. We get negative 6x. 1 plus 1/2 gives us 3/2. Distributing this in, 1/2 times 2 gives us 1. And then we're going to have, so plus x to the negative 1/2. 1/2 times 3 gives us negative 3/2. And then x to the negative 1/2 times x squared, we add those together. 2 plus a negative 1/2 gives us 3/2. So that is an answer, and that's a pretty good one. If we had to take more derivatives, that's actually the form we're going to want. If we wanted to, we could simplify it up a bit more. So negative 6x to the 3/2 plus 1 over x to the 1/2 minus 3 over 2 x to the 3/2. And then if we wanted to, we could get a common denominator of x to the 1/2. So then that would be, or 2x to the 1/2. So negative 6x to the 3/2 times 2x to the 1/2. Plus, our next one is going to be 1 times 2, because it's missing the 2 from the LCD, minus our last one, which is going to be 3x to the 3/2, and it's missing the x to the 1/2. And then all over our LCD, which is going to be 2x to the 1/2. So then, simplifying all of that together, we would get negative 12x squared plus 2 minus 3x squared all over 2x to the 1/2. So negative 15x squared plus 2 all over 2x to the 1/2. Yes, sir. So let's take a look then. At this using algebra, because we have a product, right? But the product means we can distribute it into our parentheses. So once again, we're going to note that we have x to the 1/2 times 2 minus 3x squared. If we distribute that into our parentheses, we get 2x to the 1/2 minus 3x squared. So 2 plus 1/2 gives us 5/2, right? Well, now, instead of using product rule, what rule can I use? Just the regular old power rule. So to find my derivative, f prime of x, I bring my exponent down in front, so I have 2 times 1/2, and 1/2 take away 1 is x to the negative 1/2, minus 3 times 5/2 is negative 15 over 2, and then I subtract 1 from my exponent, I get x to the 3/2. So now, if I clean this up a bit, I would have 2 over 2x to the 1/2 minus 15x to the 3/2 over 2. So I build my fraction by multiplying the top and the bottom by x to the 1/2. And I get 2 minus 15x squared all over 2x to the 1/2. So our next rule is called the quotient rule. So if we have f and g and they are both differentiable functions, and obviously g cannot be 0 because we're not allowed to divide by 0, that's bad. In prime notation, we would get gf prime minus fg prime all over g squared. So we'll notice we have a very similar formula to that which we have for the product rule. The major difference is, and you'll see me do this all the time unless I'm looking at the formula, the order we do this in, f prime g plus g prime f, if I do the derivative of f and then g plus the derivative of g then f, since addition commutes, it doesn't matter which order I write them in. And I'm especially bad at this because unless I'm actually looking at the formula, I know the order doesn't matter. It's the derivative of one times the other plus the derivative of the other times that one. And it works. With the quotient rule, the order does matter. So we have to subtract them in the proper order, or we're going to get the wrong answer 100% of the time. So just be aware. So this one's a lot pickier. So when we're going to use our quotient rule, we're going to do the same thing that we were doing before. Let's identify our f, and let's identify our g. So f is going to be e to the x, and g is going to be just x. We then calculate our appropriate primes. So f prime is e to the x, and g prime is going to be 1. So far, the quotient rule is exactly the same as the product rule. We identify f, we identify g, we take our appropriate derivatives. The only thing that's really different is when we plug in, we just have to use our formula. So we have g times f prime, and we are going to subtract from that f minus g prime. So f g prime all over g squared. So that's going to give us x times the derivative of f prime, which is e to the x, take away f, so we get e to the x times g prime, which is going to be 1, all divided by g squared, so that's going to be x quantity squared. So then, after all that, we get y prime is equal to x e to the x minus e to the x all over x squared. And if we really wish, we can factor out our e to the x all over x squared. All right, and that would be our derivative. All right, it's now your turn. All right, so let's go ahead and do this. So we identify f as x squared plus 1, and g is e to the x. So then f prime is going to be 2x, and g prime is going to be e to the x. So then our derivative of f of x is going to be g times f prime minus f times g prime all over g squared. So then we have a common factor of e to the x we can factor out, and that leaves behind 2x minus x squared plus 1 e to the x all over e to the x quantity squared. Distributing and collecting our like terms, we have negative x squared plus 2x minus 1. And then here we have 2 e to the x's, and here we have 1 e to the x, so one factor reduces out, and we get over e to the x. So then our derivative is something that looks like that. So the normal line is perpendicular to the tangent line. So whenever you hear a normal line to a curve, the normal line is the perpendicular to the tangent. So if I have something that looks like this, I have my tangent line is the same as the slope of my curve, right? So that's my tangent. The normal line is the line at that point that makes a 90-degree angle with the tangent line. So that guy is our normal. So the normal line is perpendicular to the tangent line, or using the verbiage of calculus, it's perpendicular to the curve at that point, right? So it's at a 90-degree angle to that curve instantaneously. All right, so when we hear normal line, that's really what we should be thinking. So in terms of calculus, if f prime of x is the slope of the tangent line, at x, then -1 divided by f prime of x is the slope of the normal line. Because if we remember from college algebra, two lines are parallel if and only if they have the same slope. Two lines are perpendicular if their slopes are negative reciprocals, right? So the slope being a negative reciprocal, if f prime is the slope, the negative reciprocal of f prime is -1 over f prime of x, right? So it's just the same formula from college algebra, but instead of using m for slope, we use f prime because the derivative represents the slope. So that's just our same old formula in terms of calculus. All right, so for example then, if we take a look at this guy, it says find the equation of the tangent line and the normal line to y equals x plus 1 over the square root of x at x equals 4. Find the equation of a line, we need to know two things. We need a point and we need its slope, right? Well, the point is easy, so we can calculate the point by just doing y of 4. So we plug y of 4 in, we get 4 plus 1 over the square root of 4, which is 2. So 5 over 2. So our point is the ordered pair. When I input 4, my output is 5 over 2. Now I need to find the derivative. So what rule does it look like we're going to need to use to find our derivative? Well, when we look at it, what operation do we have? Division. So what rule do we probably need to use? Quotient rule, right? So method 1 is quotient rule. And with the quotient rule, we would identify f as x plus 1 and g as the square root of x, which is x to the 1/2. And then we would have f prime is 1, and we would have g prime is 1/2 x to the -1/2. Turns out we can also use algebra So doing a little bit of algebra, if I have x plus 1 over x to the 1/2, by term-wise division, this is x over x to the 1/2 plus 1 over x to the 1/2, which then simplifies to x to the 1/2, bringing my exponent up, plus x to the -1/2. So that's our algebraic simplification. I'm not going to pursue the quotient rule. You'll get the same answer at the end. You just work a lot harder, right? So we're going to do this. So if this is my f prime is going to be 1/2 x to the -1/2 minus 1/2 times x to the -3/2. And now I need to find the slope at 4. So f prime of 4 is going to be 1/2 times 4 to the -1/2 minus 1/2 times 4 to the -3/2. my calculator, I can evaluate the following. So alpha y equals, I get 4 to the negative 1/2 over 2 minus 4 to the negative 3/2 all over 2 and I get f prime of 4 is 3/16. If you really wanted to, you could do a whole bunch of algebra and simplify that down, but you can always just feed it to your calculator after you've taken the derivative, which is probably the easiest way to do that. So we get that our f prime of 4 is 3/16. So that means our slope is 3/16, or 3/16, and then what would our perpendicular slope be? Negative 16/3, right? So now we have our point, which was 4 and 5/2. Now we just find the equation of each of our lines. So y equals 3/16x plus b, and we have 5/2 equals 3/16 times 4 plus b. 5/2 equals 3/4 plus b. And we can just do that here. So 5/2 minus 3/4. We get 7/4 is equal to b. So then we get our solution is y equals 3/16x plus 7/4. So that's our tangent line at that point. So then to find the normal line, we do the same thing, but we use the perpendicular slope. So then we have 5/2 equals negative 16/3 times 4 plus b. So we have negative 16/3 times 4. That gives us this value. And then we have on the left side 5/2. Subtract, and then to get our answer from the previous line, you press second and the negative key down here. But we don't have to type things out, and it subtracts for us, and we end up with our b value. And then we have y equals negative 16/3x plus 143/6. And that's our normal line, and that one's our tangent line. So the key thing there was the normal line is perpendicular to the tangent line. So you find the slope, then do its negative reciprocal.